Hey guys, how's it going? I hope you guys are doing well in this time with the Omicron variant going on. I hope you guys are safe. You guys wear masks, go outside as little as possible, unless you're going to see your crush. In that case, go all out, like going for candy. No, I'm just joking. Um, Hopefully this Omicron thing will clear up really soon, though, because it's like, but I have a feeling it's going to be not as bad as when the first wave came out. Because right now it's more like it's more severe than the first wave, but the first wave lasted a lot longer. And right now, most of us have, and I think like about 85 to 90% of us have been vaccinated. So like I have a good feeling about it. Anyways, let's talk about a bit about some math today. There's two concepts I wanted to talk about. The first is the principle of calculators, and the second is my general approach to math and all other quantitative courses. So let's begin with the first topic. Recently, my friend who's a first year at my university, he's majoring in like math and like engineering and such, in which case, what's wrong with you? Love yourself and don't take engineering. No, I'm just joking. And then he's like, one thing that really pisses him off is that there's no calculators that are allowed. Apparently, like, and this is common for me when I was in first year, they were not allowed to have any sort of calculators during tests. And he was like, why do university math courses not allow calculators? I think it's completely unfair because my math right now is not basic. Courses such as physics and chemistry allow calculators. So why not calculus? Why? And like, there's a lot of elements like I want to tackle this argument. The first of all is like, what makes you think having a calculator would make your calculations any less error prone? Like, if you don't have at least an approximation of where your answer should be, how are you sure that you're not going to punch in the wrong number at some point and get the wrong answer? Like, let me give you an example. Let's say you were asked to estimate cosine of pi over 12, okay? Um, how do we do that? Well, that's the same thing as cos pi over 8 or 45 degrees minus, wait, sorry, cos pi over 4 minus cos pi over 6, 45 degrees minus 30 degrees. How are you going to know that you don't punch in the wrong number at some point and get a different answer? Well, I used the addition formula for cosine, and the answer is like approximately, because I know that cos pi over 4 is 1 over root 2, which is approximately 0.71, and cos pi over 6 is like root 3 over 2, which translates to approximately 0.866. I did a very rough estimation in my head and estimated that the answer is like 0.96 approximately. And this makes sense because cosine from 0 to pi over 2 is a decreasing function. And like cos pi over 12 is between like cos 0 and cos pi over 6. And so that answer is about right. And when you type that in, cos pi over 12, you get an answer of 0.9659, so on and so on. So yeah, my estimation's right. And like, what else is wrong with calculators? That's a very good question. They lie. They lie rampantly. The other day, I made a video to you guys about trying to find the integral of root tan x dx. And if you guys recall, the answer to that was 1 over 2 root 2 ln of tan x minus root 2 tan x plus 1 over root 2 tan inverse root 2 tan x minus 1 over 2 root 2 ln of tan x plus root 2 tan x plus 1 plus 1 over root 2 tan inverse of root 2 tan x plus 1 plus c. And then I had a feeling this calculator would this online derivative calculator would mess things up. So I plugged in this really crazy expression into the derivative calculator. And you know what I got? Like, I don't remember what I got, but it was just a complete jumbled, like messy thing that like just didn't make sense. But the answer of that derivative is supposed to be root tan x because, well, for obvious reasons. Like, that's because the machine doesn't know how to manipulate multiple formulas at once. It has a certain limit or a brain capacity that the programmer set it to do. Remember, a calculator is a machine, and machines are controlled by us humans. So, like, you know, if machines become smarter than you, then you're gonna, what's the point, right? And another time, I do a bit of tutoring now. There was this girl named Michelle that I tutor for grade 8. And the other day, I was trying to discourage her for the use of calculators. It was trying to ask her to compute, draw me the graph of x to the power of 600 divided by x to the power of 600. Let me share my screen and let me show you what the results are here. Here's what a TI-92 graph draws x to the power of 600 over x to the power of 600. It looks something like this. I still remember it's not exactly accurate, but it looks something like this. This is because the calculator has gone through something called information or process overload. Because x to the power of 600 is a very large number, it becomes so overloaded that it starts bouncing around crazily. And here's what a 13-year-old girl came up with, Michelle. And I'm going to write here, priceless. At the age of 13, guys, a 13-year-old girl has better intellect than something worth $6,000, in which case, you could have spent that money buying 130 bowls of the most expensive caviar already. She drew this. X, Y, and that's 1. And it didn't cost her a dime. Well, $25 an hour, but my rate is negotiable. So calculators, like an over-reliance on them is not good. And not only that, but it's like, because then there's too many variables to consider. Like if you say, oh, professors should allow calculators here, they should not allow calculators there. And it becomes too hard to like find the middle boundary. And not only that, but a lot of calculators can now do basic derivatives and integrals. So if you allow calculators on a calculus 1, 2, or 3 midterm or final, then what's there left to do for you to solve, you know? And like in that case, if they allowed calculators, then they would have to ask really challenging questions. So then, like, I remember Professor Joseph told me, like, so we basically just we make simple questions like find the derivative of this, or find the integral of that, or find the volume of that. So well, they're not easy questions, but they're slightly less making your mind go crazy questions. So people who spend a little bit of time studying will be able to do well. If we tested really hard questions, at least 80% would fail. And believe me, it's not very difficult to come up with really challenging questions where the highest grade is 10%. Over-reliance on technology is rapidly insane. And it's actually kind of scaring the shit out of me, no doubt. Think about it now, not just math, with everything. When you don't know something, you just go on Google. When you are lost, you just go on Google. But what if one day just so happens that you're lost in the middle of nowhere in the forest, and your phone either runs out of battery or loses signal? Well, people 100 years ago didn't have phones, they had to rely on the compass or using the sun to tell time. So, I mean, it's kind of scaring me. People are becoming rapidly reliant on calculators, and people are eventually not gonna, I'm worried eventually people are not gonna do math by hand at all and just rely on calculators entirely. So right now, I really hope that they don't allow calculators. And just to give you an idea of how ridiculous it is, early on in my first and second year in college, when I TA'd, I TA'd calculus 1, 2, and linear algebra. I actually had an integral calculus student have the audacity to tell me that he didn't need to learn how to compute integrals by hand because he expected me to be able to solve the integral for him by knowing which buttons to punch into his calculator. Needless to say, the idea of smashing the calculator crossed my mind. I, of course, didn't do that, but I really, really wanted to. And also, starting at calculus, it's a big jump from pre-calculus 12 or whatever math you took before. And you need to have a good sense of number manipulation and formula derivation. So the question is, how good is your could your calculus be if your basic arithmetic is shaky? And I would say that honestly, not allowing calculators, it shows that some students struggle. It cuts out the weak people and keeps the strongest people alive. It is natural selection in its finest, I would say. So my advice to my friend, just think of it like practice. You'll stay sharp on your feet. You'll be able to derive numbers properly, and hopefully you won't be controlled by a robot really soon. The second part I wanted to talk about with math is, my basic experience with numerical courses and such. There's this really cool thing. I'm going to share my screen for a sec, you guys. So just to show you how difficult math is, look at this meme. Marijuana, cocaine, calculus. Look at this. How it feels trying to understand math. This is how I feel in my this is how I felt when I did complex analysis, guys. No lie. Baby crying. Hey, that baby is more honest than Charles Manson, though. I'll give it that. Math is no doubt difficult, and there's one more thing I wanted to show you guys, not just for math, but yeah, homework versus test meme. This is how it seems like I can definitely relate to this. In class, you learn that 2 plus 2 is equal to 4. On the homework, you learn that 2 plus 2 plus 2 is equal to 6. And in exams, Omar has 4 apples. His train is 7 minutes early. Calculate the mass of the sun. It's 5.98 times 10 to the power of 24 kilograms for anyone who cares, which I highly hope you don't. But basically the meaning of this meme is in class, it's basically you learn stuff that's really intuitive, really easy. On the homework, it seems like it has very little or no relation, or you really have to flex your brain muscles to get the answer. And on the test, it seems like it's something completely different and all that. It's a bit of an exaggeration, but I can kind of understand where it's going. This brings me to my main point of what I wanted to share with you guys. I have basically had no trouble doing maths up until complex analysis or complex variables. I don't know what your university calls it. I ended up getting a C+ in that class, partly because my teacher was a bit of a dick in marking. Hey, teacher, if you're watching this, nah, just kidding. I love you. But like it became really heavy. It became like my first experience with physics. Okay. I'll be honest with you. I was not that great of a physics student in grade 11. I only got 81% on grade 11, which was a B. But in grade 12, I got 91% in physics, which, case in point, I'm able to tutor physics, high school physics 11 and 12, if you guys need me. But here was my initial approach. I approached it the same way I approached math, basically. Like, let me just share my screen here. Bye, Michelle. Your smile will always go on. Okay, so basically, let me give you an example. Here's an example of grade 10 math. So like in grade 10, I'm sure you guys know how to factor quadratics or solve quadratic equations. I'm sure you guys know how to solve like, let's say factor 4x squared minus 20x plus 21 is equal to 0. Like something like that, right? Here's how I would do math from kindergarten to ordinary differential equations. I would pay attention. I would take notes to what the teacher or professor was saying in class. They would give an example like this. And then I would know that like, okay, 2x, the answer is 2x minus 3, 2x minus 7. I would use decomposition or factor by grouping to do it. And then basically like x is 1.5 and 3.5 from this. And then like you could give me any question afterwards and I would be able to solve it like that, because it's like you could give me 2x squared minus 17x plus 36 equals 0. I know x is 4 and 4.5. And then so on and so on. And once you gave me the quadratic equation, I was all check marks. I was the valedictorian for grades 9 to 11 math. I don't mean to brag, but yeah. This was basically how I was able to do it. So like in grade 8, the teacher would teach you how to solve a linear equation with the variable x on both sides. Gives you an example, you go home and you see a lot of similar examples, and then I'd be able to solve them out in like 5 minutes flat. But then in physics, I started to realize my method was a little not so, it started to work less and less. I did well on the first test. I got 60 out of 72. That was like sig figs and such. But grade 11 physics, I'm going to show you this. Okay, so grade 11 physics. This goes back to the meme I was trying to share with you guys earlier. Actually, I'll use the text box for this. So it'd be like something like projectile motion. In class, let me write it this way: class projectile motion. And then, like, what's projectile motion? It's basically when an object falls or something like that. Gravity has, 9.8 meters per second squared. I'm just going over what he said in class, and it's like, oh, this sounds really easy. This is not bad at all. Then on the test, it goes something like this. If a very heavy rock and a pencil were dropped from the same height at the same time, what object would land first? And then, being the idiot that I was, because I was only 16 and barely knew how to tie my shoes or pop a balloon, I realized you're just supposed to use a smoke conductor, but basically I said that the rock would land first because I saw it on an anime show. But apparently you were supposed to ignore air resistance, and like this, and this was nothing like the grade 8 math or the grade 10 math where the teacher gives you an example in class with a similar, no question was similar to this. And I felt like this was a question in class. We talked about 2 + 2 = 4. And on the test, it was like, if Bob has 5 apples and you haven't done your laundry, how long would it take to find my ex? The answer being 36 days, because I am very distanced from my ex, which is a very good thing. And that's exactly why I have a virtual background. So my ex, if you're watching this, I hate you so much. You'll never know where I am. I'm in Hawaii. Okay, anyways. It's very heavy, yeah, and then it's like, apparently the answer is they both land at the same time, because when you ignore air resistance and gravity has a straight 9.8 meters per second squared regardless, you're supposed to use that concept, but it's like, I don't understand how that applies anywhere. And then we learned about kinematics, and I remember I gave a question. Okay, let's talk about forces. Forces, okay? In class. In class, we learned about Newton's 3 laws. F equals ma. Any action force has a reaction force. So apparently, if you get -100 on your test, you were supposed to get 100%. True story. And an object at rest or in motion, yeah, like it tends to stay unless there's an external force. Then I remember something about this, though. Then in class, we learned something like, if a tight rope is supposed to, if a tight rope is attached to, if a tight rope is attached to, whatchamacallit, if a tight rope is attached to an object, a tight rope or cable, then there is a tension force involved. And then there was this question that looked something like this. I'll do HW for homework. It looked something like this. I'm making up these numbers, 8 kg. And then down here, I don't know, let's call this 12 kg. I don't have enough space. And then there's this pulley that's going on. Apparently it's going down like this. And it's like, what is T? What is the tension force? And I'm just sitting there like, what? Did we go over this in class? Am I sure I'm in the right class? And like, my friend Hansen was able to solve it first. And then I don't remember the exact answer right now. And then he said, Brian, tension force is just applied force. I'm like, what? And apparently to solve this question, you were supposed to use the free body diagram. You were supposed to use the free body diagram on each individual object. I'm not going to do it here. I'll save this example for a separate video. But you're because the teacher did talk about free body diagrams in class, and you're supposed to know that tension force is applied force. It's like common sense type of stuff. But at the time, I was thinking, who cares? Like, math is much easier than physics because it's like, they're not going to curve the question that much. At the time I was in grade 11. So like for a few more years, things were okay. Even calculus 1 and 2 weren't that bad. It wasn't until I ended up taking like ODEs, ordinary differential equations, and complex analysis when things started to become really strange. Because it's like, if you ever been to a proof-based class, it's like basically you learn something in class, you take your knowledge and you apply it to show a certain concept exists. And I was told by Hansen that I would cry with my method in the future. And he must be a seer because I did end up crying. What I'm trying to tell you guys is like the way I do things isn't so good anymore. I try my best to explain every concept to you guys and present every possible scenario, but like why? But I want you to guys to understand why certain solutions exist behind my styles and such, and why things happen. Don't just take it for granted. Don't just give me the benefit of the doubt. Question, because then you could just change the case a little bit. Because if you just know how to do one scenario, I could just change the case a little bit. And then all of a sudden you don't know how to do the question. So yeah, man, this has been really tiring. I hope you guys enjoyed this video. This was something very important for me. And even if this video doesn't get that many views, like hopefully I can watch this back, look back on this in 10 years and, remind me of these important things in life. So yeah, hope you guys are well. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.